Hey, what's good, everybody? Welcome back to my channel, right? It's the Incredible Academic speaking. So we are just gonna, carry on with calculus. A couple of questions that I want us to, look into. Yeah, so we are getting asked to show that a is equals to -1, b is equals to -1 as well, and then c is equals to 1. I'm hoping that you guys can see my handwriting over there. So the function as well, y is equals to x cubed plus ax squared plus bx. So we don't have the a, the b, and the c, but we do have the coefficient of x cubed. Right. Determine the coordinates of the turning point, right? Of the turning point. So the first thing that we asked is show that a is -1, b is -1, and c is equals to 1. That's the first thing. So the question that you're seeing up there, it's actually the second question. So let's look closely what we are given. All right, we do have one turning point. We also have a root. Okay, we have a root. So let's see how we can work this out. How can we find a, b, and c? Right. So all right, but remember this turning point here, it's also what? It's also the root. Very, very important. Okay, and you can see that our function is actually kissing the x-axis here. So that means that now this is a double root, right? That means the function that we have has got two equal roots. Why? Because it's kissing the x-axis. All right, so we basically have all the three roots, right? Because the first one is -1, the second and third, that's 1. So remember, we've got this equation, all right? Y is equal to a, and we already know what the a is. Remember, the coefficient of x cubed is 1, so we already know what the a is. So a, x minus √1, x minus √2, and then x minus √3. Okay, super easy to find the equation when you already have the three roots. So the a, the coefficient of x cubed, that's 1. So we're just going to leave it as it is. Here in place of a, it's 1. So 1 times the whole thing. We just left with the whole thing. So now x minus √1. Remember, √1 is -1. So that's x plus 1. So minus 1, that's plus 1. And then x minus √2. Remember, it's 1. Even 3 is just 1. So x minus 1, also x minus 1. So there we go. So now we just need to multiply this out. So x plus 1 into x what? Well, we could just multiply this out, but I think the easiest way to go about it, because the two are actually the difference of 2 squares. So this is x squared minus 1, and then multiply by x minus 1, right? Yes, so you've got to avoid taking the long root. So x times x squared, that's x cubed. X times -1, that's -x. And then -1 times the x, that's -x again. And -1 times -1, that's plus 1. So our answer is what? X cubed minus 2x plus 1, right? So this can be rewritten as x cubed plus 0x squared plus what? Minus 2x plus 1. So you can see that the a is 0, the b is -2, and the c is 1, right? So we're actually asked to prove. So yes, B is, but our answers are different. Only C is equals to -1. Right, so that is a problem. But let's go back and check what happened. All right, let's go back and check what happened. Maybe you might be able to figure out why we are getting different answers. So yeah, I just want to try and debug and see why they're not corresponding. So just a couple of seconds just to debug a little bit. Right, x minus 1, x minus 1. Oh yes, now I see what the problem was. So okay, this was supposed to be x squared, right? So that's what the mistake was. So x squared, x cubed minus x squared, and then minus x and then plus 1. So that's what the problem was. I'm sure you guys picked it up. So now you can see the coefficient of x squared, which is a, that's -1. So a is -1, b is also -1, and c is +1. Nothing as boring as getting stuck, right? But anyway, we managed to prove. So always when they say prove, make sure that your answers correspond with what's already given. Okay. So now B, determine the coordinates of the turning point of B. So remember, we've got two turning points. There's 1 is to 0, and then there's the other turning point, which is B. All right. So how do we go about doing that? How do we determine the turning point? So I mean, we already have the function, because we know that B is basically given by what? B is basically, the x coordinate of B is basically the other root, right? The other root for the gradient of the tangent. So what is the gradient of the tangent? So we know that, okay, y is x cubed minus x squared, right, minus x and then plus 1. So y prime is what? 3x squared minus 2x minus 1. Right, so this is equal to 0. So we need to solve this. So 3x and then x, right, and then what do we need to substitute here? So we're just gonna say 1 here, right, minus, and then plus 1 there. Okay, is equal to 0. So obviously we need to double check if this is actually correct. So 3x squared minus 3x plus x. So minus 3x plus x does give us minus 2x, and plus 1 times minus 1 does give us -1 over there. So our factorization is correct. So we set everything equal to 0. 3x plus 1 is equal to 0, or x minus 1 is equal to 0. So x is equal to minus 1 over 3, or x is equal to 1. Right. Well, alternatively, you could have used the quadratic formula here to find your roots, and it was gonna, you know, work out perfectly. You know, the quadratic formula, it's super great. You know, yeah. If you really want to make sure that you collect your marks, I would suggest you use the quadratic formula, because some people they just don't have the ability to run a check just to see if, you know, the factorization is correct. You understand? So that's why I highly recommend the quadratic formula. But if you can be able to check after factorizing if your factorization is correct, then well, you're better off with factorization. Okay, so we know that B has got its x, you know, coordinate as -1/3. So now let's go back to the original function and substitute 1/3. So y of -1/3, so -1/3 cubed minus 1/3 squared, and then minus 1 over 3 plus 1. So we're going to need a calculator for that. So we've got minus 3 to the that, that's the same as minus 1 over 3. So answer cubed minus answer squared minus ans plus 1. So our answer is basically 32 over 27. So B is basically 32, minus 1 over 3 is to 32 over 27. Right, that's B, the other turning point. Okay, so next question. Right, so determine the equation of the tangent to the curve at x is equals to 2. Okay, the equation of the tangent, not a problem. So to find the equation of the tangent, obviously we need to have one point and the actual gradient. So to find the gradient, we just need to use the gradient at x equals to 2. We just need to use this formula here, because remember, this is the gradient formula. Okay, this is the gradient formula. So now we're just going to say, all right, so now we're just going to say y double prime at 2. So what is the gradient at 2, at x equals to 2? So we're just going to substitute. So 3 at 2 squared minus 2